Hi friends, I am developing this video based on Anna University ANSYS Practical Simulation Laboratory. With these videos, you can develop your problem solving skills using ANSYS analysis software, and you can able to solve all types of problem which is given as Anna University exercises. Under this, we have an exercise called Truss analysis. This is the truss structure and the material properties, Poisson ratio, and the area of cross section are given. Now, how you can approach this type of problem using ANSYS software? First, open ANSYS, go to Preferences, select a structure since it is a structural analysis, click OK. Then go to Preprocessor, element type, add, edit, delete, add. Since it is a truss element, you have to select element type as link 3D finite ST in 180, click OK, then close this one. The next thing is to define the cross section of the element, truss element. For that, you have to go to real constants, add, edit, delete, add, click, it will show the element what you have chosen before in the element type, click OK. It is asking the cross-sectional area. What is the cross-sectional area? The cross-sectional area is 4 meters square. But everything we have to give in ANSYS as mm. So for that we have to convert from meter square to mm. So 4 e power 6 to convert to mm. Okay, is it right? Click apply. Then okay. Now here the set 1 has been indicated where the cross section has been saved in this real constant, and close this one. Then the next thing is to give the material properties of the element. So go to material property, material models, structural, linear, elastic, isotropic, 2E5, which is given in the question, and Poisson ratio 0.3, Poisson ratio 0.3, click OK, then close this one. Now we have also given the material property. The next thing is to create our section or structure. For that, go to modeling, create nodes in active coordinate system. In active coordinate system, it is asking the node number and the coordinates. The first node where we have to create is 0, 0, 0, which is this point. Okay, from this point only we have to create a node here, here, and here. Okay, for that the initial raise hidden, the initial node number is 1, 0, 0, and apply. Now I got a node here at 0, 0 point. The next node number 2 has to be created at a distance of 3000 mm from node 1. Okay, node 1 raise hidden 3000, then apply. Now I have got a node at a distance of 3000 mm. The next node has to be created 3000 in y. Okay, see 3000 in y. Then the s coordinate will be 0. Okay, raise hidden, s coordinate will be 0, whereas the y coordinate will be 3000. Apply. Now you can see the node has been created here. The y coordinate at a distance of 3000 and s coordinate at a distance of 3000. The next is this node. In this figure, the distance is not given, so we can create a node here itself, which is 3000, 3000, where the node will be created here. Okay, extend to here. Okay, go to raise it down, enter the node number of 4, 3000, 3000, or else we can give x coordinate as 2000 and y coordinate also 2000. Okay, sorry, it will not be because it's in length. We can 3000 comma 3000, which is the node here. Okay, 3000 comma 3000 plus okay. Now we have got the 4 nodes. Okay, now we have to link these nodes. How we have to link these nodes? Further, go to elements, auto number through nodes, select this node and this node, apply. Now we have got this element. Now we have to get this element and this element. Okay, for that again select this node and this node, press apply. Now we have got the vertical element. Now this element, click this and click OK. Now we have got the 3 elements. Okay, yes. Now the next thing is the boundary conditions. What are the boundary conditions? No, the endpoints of these are fixed. The node number 1 where we have created 0, 0, it is subjected to a point load in y direction and x direction. It is negative x and negative y. Okay, yes. For that, go to give the boundary conditions, you have to jump from preprocessor to solution. Under this define loads, apply structural displacement on nodes. Okay, select this node and this node and this node, which is arrested to all degrees of freedom to 0. Okay, yes. The entire node, the n nodes are arrested to all degrees of freedom. Now the point load has to be given here. What are the point loads? 20 kilonewton in negative y direction and 10 kilonewton in negative s direction. Okay, yes. Further, go to force on nodes, select this node, apply. First we have to give negative x direction. Negative s direction means minus, what is the value? 10 kilonewton. Raise it on 10 kilonewton to newton. Okay, 10,000. Okay, 10,000. Apply. We have got a point load like this. Then again click OK. The next thing is to give the load here. Okay, for that again go to force moment on nodes, select this node and press OK in y direction. So you select as direction of force in y. What is the value? 20 kilonewton. Yes, it done. So 20,000 minus 20, 1, 2, 3,000. Okay, click OK. Now the load has been created here and here. Yes, the boundary condition has been successfully given using ANSYS. The next thing is solve the current load step. We instruct the ANSYS to solve this problem. For that, close this define loads, solve current ls, press OK. The solution is done successfully. If there is any error, it will be indicated here. Close this one, close this one. Now we have to review our results. For that, you have to jump from solution to general post processor. Under this, plot results, deformed plus undeformed, deformed plus undeformed. Okay. See, due to this load, the truss element is deformed like this way, which is shown here. You can also visualize this in 3D. For that, go to plot controls, style, size and shape, on and click OK. 3D see. Okay. Also again convert to 2D size and shape off 2D Now we can also review our nodal displacement, nodal solution, nodal displacement, UI of solution, displacement vector sum. Now you can see the displacement value here. Okay, can also review the stress results. For that, go to nodal solution, stress. I'm selecting 1 mass stress. It is highlighted in red color. Visualizing in 3D. Style, shape on. You can see here this element is totally affected by the stress, whereas this element and this element is not affected too much. Only this element is affected. You can see here. Hence, we successfully completed this type of problem using ANSYS Mechanical APDL software. Thanks for watching. Have a nice day.